Okay, we are working here with section 1.8 in the pre-calculus book. This is on graphing inequalities. For the most part, this should be a review of some things you've done in Algebra 2, but it's good to kind of go through and do this review. So we're going to start with how do we graph an inequality, a linear inequality? And what we do is we start with graphing a line. So we say, what would it be if we had y equal 3x minus 5? And so we're going to actually graph that y equals 3x minus 5. We're going to start here with 1, 2, 3, 4, 5 as our y-intercept. Our slope is 3, so we're going to go up 3 over 1, up 3 over 1, up 3 over 1, and we have a good line there. All right, so then we have to say, where do we want to shade? Because now our next step is we're going to be shading, and we have to decide, are we going to shade here in, I'm going to call it zone 1, or yeah, we'll call it zone 1. And are we going to shade here in zone 2? Only one of them should be shaded. There's a couple ways you can think of this. One way is to say, okay, how do we decide where we're going to shade? One way is to look at a point in one of the zones and choose that point and say, hey, would that be a true statement or a false statement? If it's in the point and it's a true statement, that's where you should shade. If it's not, you should shade in the other statement, or in the other zone, excuse me. So let's try this. We are going to try what's called a 0, 0 test. We're going to check the point 0, 0. So for y, we're going to put in a 0. Is 0 less than or equal to, for x we're going to put in a 0, so 3 times 0 minus 5. In that case, we're asking ourselves a question. We're saying to ourselves, okay, is 0 less than a negative 5? The answer to that question is no, 0 is not less than negative 5. So since this was a no, we are going to be shading here in zone 2. That's where we want to indicate, because of that less than or equal to, that it could be anything in this zone would be a true statement. That line just tells us to know where is our starting value. Where do we start to do our shading? There. We know it's not going to be here in what we had as zone 1 because of our 0, 0 test. Now there are a lot of you too who can just use logic and say, okay, when it's less than, I can think here is where, and I'm going to use a different, I'm going to use red. Here is where y gets smaller. So when it's less than, a lot of people just shade below. And so y gets smaller as you go down, and so they're going to shade below. I don't care how you think of it. I just want to make sure, and the 0, 0 test is just a good way to make sure that you're accurate. Let's look at another one. So here we're going to be looking at first graphing y equals negative 4. So we have to decide on our y, here's where y is negative 4, and then the equation y equals negative 4 would be this line. We need to graph greater than or equal to. Okay, greater than or equal to is above. All where you just, in this one you're going to have to more use logic. You could put in a 0, 0 test, but really this is one where logic should kind of win over here. So there's, we just shade, and just kind of shade it in with your pencil is what I'd be looking for. Now, we haven't talked about this, but what if, I'm asking, what if it was not greater than or equal to, but just greater than 4? How would we handle that? There's a couple ways we can handle it. The way I would do it is I would take the exact same graph, and then just right below it, I put a dash line to indicate, hey, it's not that line, but it's kind of everything right above that line. So it's like that line is important in our starting point. But I like to put that dash line right below. Some people like to make that line dashed. I don't care which you do. You know, whether you make your line dash or you put your dash line below, it doesn't matter to me. Somehow indicate that you realize, though, that there's not an or equal to, that it's just a greater than. 3x is greater than or equal to 12. Now we're dividing here by 3 to solve for x. We want to have just what is x all by itself. X all by itself is greater than or equal to 4. So let's see what the graph of that would be. Here is where our x equal 4 is. Here's the line, kind of a nice little line. Where does x get higher or greater? I'm thinking over here. There we go. And you just have to shade it in. So that's the graph of x is greater than 4. Next one. Let's try the first one on your worksheet. And this is off the 1-8 worksheet that you have. What I would do here is I would first solve, number one, I would solve it for y. I want to have what y equals. So the first thing I would do is I'd switch the two parts around. And the thing you have to remember is you have to switch the inequality. A lot of times what I think to myself is the open end of the inequality is facing the y, and I want it to keep facing the y. And so that's what I did when I switched it around. Next thing I'd do is I'd rewrite this so that it's a y equal or y greater than equation. So I'm going to subtract 2 from each side. Now this is in the form of mx plus b. Now I can graph this, and it's something that I'm used to graphing. Starting with my y-intercept, my slope is a -2, so I go down 2 over 1, and I could draw my line. Nice straight line there. Now I need to graph, or I need to decide where am I going to shade. I'm going to shade above, on the idea that a greater than usually indicates where y is going higher, which is right here where y gets higher. So a greater than or equal to me indicates above. I have no trouble if you're like, I'm going to do the 0, 0 test. And if we did the 0, 0 test here, we would have that 0, and we'd be asking ourselves the question, is 0 greater than 3? And the answer to that question is no. So where 0, 0 is on the graph should not be shaded, and we fulfilled that, so we're okay. I want to do an absolute value equation with you. So I'm jumping ahead to problem number 8 on your worksheet. So you might want to find that on your worksheet. Now the first thing I want to do here is I want it where it's in terms of where y is first. So I'm going to rewrite this. Again, it was pointing at the y, and I'm going to put x minus 1, the absolute value, minus 2. Now if you remember from graphing absolute value, usually the absolute value starting point is 0, 0, but because of this -2 here, it means go down 2 from there. This minus 1 actually means go right 1. So our starting point is going to be at the point 1, -2. It's like the slope here is a 1, so it's like you're going to go up, 1 over, 1 up, 1 over. Same thing here, it's 1 up, 1 to the left, 1 up, 1 to the left. And that's our graph of the equation, y equals the absolute value of x minus 1 minus 2. Now let's think about what is it because it's less than. We have a less than here. So I'm going to graph below. Less than to me means below. Again, we could have done the 0, 0 test. So let me go through what the 0, 0 test would be. The 0, 0 test would be putting in a 0 for your y and putting in a 0 for your x. Excuse me. So then we would have 0 is less than 1 minus 2. You're asking yourself the question, 0 less than -1. The answer to that is no. It's just coincidence that these three have been a no when it comes to the 0, 0 test. That's not always true. So here we just know at 0, 0 is not where we're going to shade, so we knew we shade on the other side of our line, and our line happens to be a V here. So I do want you to complete the rest of that worksheet, that 1-8 worksheet. If you're in the hybrid class, the worksheet's on the Moodle site, and the answer key is on the Moodle site as well. So don't hesitate to let me know if you have any questions.